Tutto esaurito per il telescopio spaziale James Webb della NASA e dell'ESA. Il primo anno delle sue osservazioni è già prenotato con una lunghissima lista di zone dell'universo da osservare, dalle atmosfere dei pianeti alieni alle origini delle galassie. La comunità scientifica italiana guidata dall'Inaf non vede l'ora di incominciare. Silvia Rosa Brusini.
And liftoff.
Décollage.
Decollage, liftoff from a tropical rainforest to the edge of
Il più grande, il più potente, il più costoso, il più complicato telescopio spaziale della storia ha incominciato la sua avventura il giorno di Natale. Ma si può dire che se il lancio vero e proprio è tecnicamente finito e la traiettoria è perfetta, siamo solo all'inizio dell'inizio. Quando James Webb si è staccato dall'ultimo stadio del razzo era a 1400 km d'altezza e in accelerazione verso il suo obiettivo intorno al Sole, dove arriverà tra un mese. Questa è l'ultima volta in cui l'umanità ha visto il telescopio che scoprirà come tutto è nato. E il primo anno del suo lavoro è tutto prenotato dalla comunità scientifica di tutto il mondo.
Quindi sono state circa 1200 proposte e ne sono state selezionate un pochino più di 250, 266 per la precisione, per il primo anno. Quindi con una percentuale di circa il 25%, quindi diciamo una competizione molto forte.
6.000 ore d'osservazione, 250 giorni di tempo di lavoro del telescopio. Si sono aggiudicati il privilegio di usare James Webb Telescope una decina di programmi tutti italiani, la maggior parte dell'Inaf, un paio di università, ma tanti sono gli scienziati italiani coinvolti anche in altri progetti internazionali.
La nostra comunità italiana, partecipando insieme con le altre collaborazioni, chiaramente siamo molto interessati proprio all'origine dell'universo, quindi nelle prime fasi di formazione delle stelle. Webb andrà più in profondità rispetto a Hubble e quindi ci sarà questa fase eccezionale poco conosciuta ancora in cui le galassie si formano e noi abbiamo una tradizione di grandi studi su questo. E poi come evolvono da dei grumi un po' informi, un po' anche diciamo così strani a vedersi, alle bellissime galassie che tutti quanti siamo abituati a vedere, spirali perfette, diciamo. Quindi come questa evoluzione avviene nel corso del tempo è molto complicato da capire perché ci sono interazioni tra le galassie, c'è una partecipazione in qualche modo anche di altre forze tipo la materia oscura che sicuramente informa diciamo un po' tutto l'ambiente delle galassie e le galassie stesse, per cui questa evoluzione noi adesso la potremo studiare con questi potentissimi mezzi.
Hello, welcome to the program. I'm Hashim Ahalbarra. Humankind has embarked on another space adventure.
3, 2, unité, top.
One of the most sophisticated technological systems ever created on Earth is on its way to make history and to look back in it. The James Webb Space Telescope is the largest and most powerful space observatory to be launched into space, and with a price tag of $10 billion, it's one of the most expensive. After nearly 3 decades in the making and now on a closely watched voyage of 1.5 million kilometers, scientists are hoping it will allow them to look at regions of space never seen before. Once it reaches its destination, the telescope will look back in time by capturing infrared light from the early universe. That will allow us to examine the creation of stars and galaxies and maybe unlock new clues about our existence.
The launch is of the order 80% of the risk in a mission. I would say, kind of by our analysis, but kind of by various ways of assessing that, here it may be 20% of the risk of the mission, perhaps 30, I don't know. And so basically what is ahead, we have retired a number, quite some risk, but what is ahead remains a risk that we're going to take down step by step.
I'm very happy that Ariane 5 was performing extremely well, which also means that there's a lot of time ahead for good science because good orbit injection allows to have more fuel on board of the spacecraft.
Ariane 5 and Arianespace have perfectly delivered for this mission. All the parameters of the flight are excellent and perfect as scheduled.
We'll begin our discussion in a moment, but first let's take a look at some of the most significant moments in humankind's quest to explore space. Sputnik 1 was the first satellite successfully launched into space. It went up at the height of the space race between the US and then Soviet Union during the Cold War. Soviet cosmonaut Yuri Gagarin became the first human to travel into space and return safely after completing a full orbit of our planet Earth. The moon landing was one of the most awe-inspiring events of the 20th century. Astronauts Neil Armstrong and Buzz Aldrin reached the moon and walked on its surface in 1969. 20 years later, the Hubble Space Telescope was launched. It allowed scientists to discover moons, planets, and galaxies never seen before. In 2004, Spaceship One became the first private crewed spacecraft to cross the boundary of space above Earth. That made South African pilot Mike Melville the first commercial astronaut. Let's bring in our guests in Boston. Avi Loeb is Professor of Science at Harvard University and author of Extraterrestrial. In Bristol, Elizabeth Pearson is an astrophysicist and space journalist. In London, Francisco Diego is Senior Research Fellow in the Department of Physics and Astronomy at the University College London. Welcome to the programme. Avi, this has been characterized as the most ambitious astronomy mission of NASA. Why that characterization in particular?
Well, for several reasons. One is that the telescope will be in the Lagrange point 2, which is 1.5 million kilometers away from Earth. It's about 3,000 times farther than the Hubble Space Telescope is, and service is not an option. So it's very ambitious for us to send the equipment that far and hope that it will work perfectly as it did so far. The second is that this telescope will take the deepest images of the universe, piercing back in time to when the universe was only hundreds of millions of years old. That's when the first stars were made, the first galaxies, and we have a chance of getting the scientific version of the story of Genesis. Let there be light.
Elizabeth, is it particularly because of that reason mentioned by Avi, which is basically that need, that quest that humanity started quite some time ago to understand how the universe began?
Yeah, there is definitely, I've been reporting on space and space science for over a decade now. And one thing that you've learned in that time is people absolutely have this, it's sort of inherent need to understand what's going on with this universe around us. And, whether people do that with like religion or science or, some combination of the two. But it's definitely one of those things of whenever you get these big missions, ultimately the question comes down to like, why do people put on these missions? And it's just that fundamental human need to know what's out there and to understand. And Webb is going to be a really good tool in our toolbox of being able to do that, because it will be able to look at these parts of the cosmos and these parts of the universe that we've never been able to see before because they've been shrouded in dust. That's what infrared is so good at. It's piercing through that veil of dust that you find, throughout the entire universe. So you can look right back to the beginning of time, or the dust that's surrounding, stars as they're growing, or planets and things. And so I think Webb is really going to help us get to grips with answering those big questions.
Francisco, is it because it operates in infrared that the chances are really high that it will be able to capture the images of the galaxies, the stars that first glowed after the Big Bang, which is going to be an uncharted territory or perhaps a turning point for astrophysicists?
Yes, the James W telescope comes to fill a gap in what we call the electromagnetic spectrum. The Hubble Space Telescope is observing the visible part of the spectrum and a little bit of the near infrared, And then the James W is going to observe from the near infrared to the middle infrared, which is the important window, which is a bit neglected. It has been observed before, but not to this level. And then, of course, we have the Herschel Observatory that was working a few years ago, observing the far infrared, which is also very interesting. It was a very successful telescope, also in Lagrange point, in the Lagrange 2 point, with a mirror of 3.5 meters. It was quite a big telescope, almost as big as this one. But yes, it is very important to observe in this part of the spectrum to locate, as you said, the very first stars that emerged from the dark ages of the universe. A few 100 million years after the Big Bang, we have these stars emerging, and the first kind of building blocks of galaxies, sort of proto-galaxies that are going to merge together. We still don't know how this process took place, and this is where the information is going to be very useful.
Ladies and gentlemen, from what you're saying, from the expressions of your faces, this is quite an incredibly exciting moment. But just for someone like myself, I want to understand that you have to put something like $10 billion into this sophisticated design. This is my question to you, Avi. And then you still have to wait for 6 months for the telescope to unfurl and then for the mirrors to spread. If that doesn't work, it's total failure.
Well, yes, any challenging task is also a risk, but it's definitely worth it, and the time that we are waiting is much shorter than the age of the universe. The reason that we want to look in the infrared is that even if you take the sun and place it very far away at the edge of the universe, the radiation will be stretched, the wavelength will be stretched to the infrared, such that the visible light that we see close to the sun will become infrared light as a result of the expansion of the universe. And in fact, the first stars, and I've been working on this frontier for 3 decades, I wrote 2 textbooks, the first stars are expected to be even brighter in the ultraviolet than the sun is. They are expected to be very massive. And despite this, what we see would be in the infrared because of the expansion of the universe. And the James Webb Space Telescope can tell us what our ancestors were. What are these building blocks that were formed first and led to the production of heavy elements that we are made of. So in a way, it's our origins that we are uncovering, and it's worth every penny to figure out where we came from.
Elizabeth, the telescope will be in an orbit which is not the same one as Hubble. It's going to be behind the Earth in L2, which is about 1.5 million kilometers from the Earth, which means that if there's any glitch, there is absolutely no way you will be able to send any rescue mission there. What's the rationale? What's the rationale behind this particular thing, putting it on L2 when you know this is one of the most expensive telescopes created by, designed by NASA and other groups, and then there is no rescue mission?
Well, to be honest, even if it was closer to Earth at the moment, there's no rescue mission. When there was Hubble, there was the space shuttles were operational, and that was what went and did those servicing missions. We don't have those anymore. So even if there was something wrong with Hubble, you'd have to build an entire, spacecraft to go and be able to deal with it. And if you're going to have to do that in low Earth orbit, you might as well do it 1 million miles away. It's the same thing. But that said, there are a lot of really good reasons why you want to be at L2. One is because it's a gravitationally stable point. That means as you go around with Earth, it's basically dragging you along in time with the Earth. So it's always going to keep pace with us, which makes communications much, much easier. It also means that it's going to be able to operate 24 hours a day. At the moment, Hubble, because it's going in orbit around the Earth, it can only actually observe when it's not pointing at the sun. So when it's on the other side of the Earth. So half of its time, it can't observe. And I don't know about you, but if I'm spending $10 billion on a telescope, I want it to be able to observe 24 hours a day. And finally, it's also very, very thermally stable over there. So as Hubble goes from night to day to night to day, it's cooling up and warming down and going back and forth between those two temperature things, which very slightly deforms the mirror. And on something like Hubble, because it's only got a 2.5 meter mirror, you can't really notice that. Webb, with its 6.5 meter mirror, that would make a huge difference, and you'd be having a slightly blurred image. So it definitely is worth it. It's a bit more of a risk going all of the way to L2, but people have been spending a long time making sure that everything is going to go to plan. And that's one of the reasons why it costs so much, is because they know it can't fail, so they ensure it they can.
Francisco, if Hubble was quite instrumental in shaping our understanding of the expansion of the universe, black holes, could James Webb be quite instrumental in our understanding of how the universe started about 13.7 billion years ago, if that's the most accurate estimate yet to be proven by James Webb?
Yes, 13.8, I think, but yes, I think you're right. They complement each other. In fact, it was said many times that the James Webb is going to replace Hubble, and it's not. They will be working together at the same time for several years, and in fact, it's probably that the James Webb is going to run out of fuel, because it has a fuel hydrazine that is going to help to point the telescope in different directions during the several years of operation. As soon as it runs out of that fuel, it will be out of operation. The Hubble Space Telescope doesn't have that limitation, and it will continue. So probably the Hubble Space Telescope will outlive the James Webb. But both will work in coordination. And one will be a fantastic opportunity for science, because they are going to cover the whole spectrum all the way to 25 microns or so.
Avi, it is going to look deeper into space, towards the edge of time, but at the same time it will take opportunity to look into our own solar system and look for building blocks of life somewhere in this massive expanse of the universe. This looks like a mammoth task, never undertaken before by humanity.
Right, so this telescope will be able, for example, to look at the atmospheres of planets as they transit their star, as they pass in front of the star. And some of the light from the star would pass through their atmosphere, and we can diagnose that light and figure out if there is any fingerprint of molecules that we recognize, such as CO2, water, H2O, and methane, CH4, and by that perhaps find evidence for molecules that are indicative of life. I should say I took part, I was very fortunate to serve on the first advisory committee that designed the James Webb Space Telescope back in 1996. And back then it was called the Next Generation Space Telescope, NGST. And it took a long time, a quarter of a century, for it to come to fruition. And really the most exciting part is yet to come. What we will find. Will we find evidence for life elsewhere? Will we find how the stars were made, the first stars? And by the way, I wrote 2 textbooks about that. And obviously, you want the forecast to be true, the predictions that we made to be true. But if they turn out to be wrong, that would be even more exciting, because we learn something new.
Mm-hmm. Elizabeth, for us and for our viewers, space and the universe makes sense only when we have a tangible look at things like spiral galaxies, planets and stars, which makes sense to us. Now, because this is going to be extraordinary in the sense that it's aiming to look for light about 250 million years right after the Big Bang. So in terms of images which are going to be sent back from James Webb all the way towards NASA, what are we expecting to see here? Make it easier, make it easier for us, for the hundreds of millions of people all over the world, really looking forward to see what happens in 6 months from now.
You do actually make a really good point. In fact, I think NASA has a policy that all of their planetary probes have to have a camera on, because they realize just how important it is to be able to show these pictures to the waiting public. People want to see and be able to connect. That said, the James Webb Space Telescope is going to be looking in the infrared, which isn't the wavelengths that we can see with our own eyes. So it's not going to be a picture that you might recognize normally when you're looking at a galaxy. So it probably will look quite unusual. Exactly what they look at depends on how people are going to set them up. because all of these images are what's called false color image. So you take a wavelength that you can't see and assign it a color that you can see. And then you put all of these together and they create these beautiful color images. And I'm sure there will be a lot of people at NASA making sure that, well, and other institutions around the world, because this is an open instrument to the entire community. Lots of people are going to be using the information from it. But they will be making sure that these pictures are, you know, understandable. Because again, we are humans, and humans process colors and things that we can understand. Images are one of the easiest ways for us to process data. You know, as a scientist, that's the reason why, you know, you plot everything on a graph rather than bugging it on a table. And pictures are a lot easier to understand. So yes, there will be a lot of people making sure that you and everybody else in the world has some pictures that will really help understand what's going on.
Francisco, we are putting massive investments here, which takes decades of time to try to put into practice. Is it because we want to understand the very structure of the universe, or is it just because we as humans, mortal, we're still grappling with the need to understand who we are, where do we come from, and how did the universe start?
Absolutely. We are filled with curiosity. Remember, the telescope was invented only 400 years ago. And then if Galileo could see what we are doing today, this is absolutely amazing. I mean, this telescope can observe from the very beginnings of the universe, the first light of the first stars, the first galaxies, to the formation of solar systems, because now we know, I mean, if Newton, Galileo, all these people, they knew the amount of planets, I mean, more than 4,000 planets already discovered by these space telescopes, actually, like the Kepler mission, with these planets that are going to be explored even further, trying to find, as Abby said, the signatures for life, especially oxygen. When you have free oxygen in the atmosphere of a planet, that's unequivocally almost a signature for life, for photosynthesis, for microbial life, all these kind of things. Formation of solar system, formation, the life itself, plus examining the planets in our own solar system as well. A very versatile instrument that's going to give us a broad view from the near universe to the very far universe.
Could we compare this to the moon landing? Shall we say that this is as important, scientifically speaking, as the moon landing? Or potentially it could be much more important than that? It could be a turning point.
Well, it all depends on what we find. It's a fishing expedition, and it depends on what fish we find. And I should say that even though the infrared sounds weird, the nearest star to the sun is Proxima Centauri, and it has half the surface temperature of the sun, roughly 3,000 degrees instead of 6,000 degrees. And so it emits mostly infrared light. And there is a habitable planet close to it, Proxima b. And if there is a civilization there that builds a space telescope, they would see the images with their own eyes, because their eyes were tuned to the infrared light emitted by Proxima Centauri. So the fact that we find it weird to look at images in the infrared is simply because the sun produces mostly visible light. And as biological creatures selected by Darwinian evolution, we have eyes that are sensitive to the light that the sun produces. But infrared is produced by our nearest neighbor.
Elizabeth, theoretically speaking, if you are chasing a light that has been traveling for 13.7 or 8 billion years, most likely by the time we detect it, the star itself or the galaxy is no longer there, which takes us to the point where do we really have to care a lot about the notion of the edge of time when time itself remains very relative? There might be a need to reset the time itself or to go back to negativity or negative time.
Well, to be honest, actually, if you're looking back 13 billion years, which is right back to the sort of beginning of when things started to turn on, basically, and it started to shine in lights that we can pick up. Some of those, actually, the first generation of stars were very short-lived. They live fast and they die young. But the galaxies that they were creating, most of those are still around, or if they're not around by themselves, they are merging with others. And you're looking back at the beginning of those galaxies, the beginnings of the stars and galaxies that then went on to build together to create the universe that we are living in today. And that's the big goal. Because this time takes so long to travel, you are seeing things as they existed right when the first stars started shining, the first galaxies started coming together. And that's what's really exciting. Unfortunately, looking before that, so the first couple of 100,000 years after the Big Bang, there wasn't much producing light. In fact, there was various phases where light couldn't travel more than a few, nanometers. And so we'll never be able to look back at that time with telescopes.
Sure. Francisco, less than a minute. Could we say ultimately that in 6 months from now, we will only say it was really worth it if we get the first glimpse of the most distant galaxy in the universe, or the most distant star, or the oldest cloud ever to be detected? That could be the moment that would be widely interpreted as, you know what, we're moving into really uncharted territory here in science.
Well, absolutely, yes. Absolutely, yes. We are using the technology at the top range of our capabilities. And as we speak, the telescope is crossing the orbit of the moon already, and is on its way very slowly now, it's 1 kilometer per second, and deploying all these shields and everything, aligning the mirrors, as we said before. And then in 6 months' time, we will get these fantastic discoveries. I'm very positive that it will work fantastically. It will be a major milestone in our knowledge of the universe.
Really fascinating to see how humanity is using the extension of its own senses to further gaze into the heavens and look for small details that are about to make massive difference in this life. Avi Loeb, Elizabeth Pearson, Francisco, Diego, I really appreciate your insight, and looking forward to talking to you in the near future when the first images from James Webb will be beamed into our living rooms. Thank you.